So okay, so we are going live. Okay, so this is what I did a few days ago. It's basically solving a C programming paper for electrical engineers. Now the paper was quite very simple, so a software application written in C language is required to perform useful impedance calculations. So the useful impedance calculations requiring here is basically this RLC circuit, where you need to calculate the impedance of the circuit. So you have your AC power source. Now, so the problem was solved a few days ago, and it was basically easy. We wrote a couple of C programming codes and variable definition and everything that you need to know about writing a fully working C programming. So this is these are basically your output consoles, as you can see. So the first one is what you see here. You have a selection SRX. So X will be for exit. So basically the program exit if I hit X. So if I select the X right now, as you can see, the program is exiting. So this is basically as a result of the switch statement here. So we are selecting switching from the character that the user is returning, and when we jump to case X, we exit the program. So if you understand how your basic switch statement works, so that's exactly how it works. So now when we run now the other parameters, so if we test for S, so this is an example for S. So basically we are required to enter, okay, a frequency value. So if I enter my parameters, so that is the 200 ohm, okay. Now you see I'm getting a problem there. It says invalid selection because I did enter indeed an invalid selection. So I first need to enter S. So if I enter S, okay, so if I enter S, then it's asking me to please enter a resistor value. Now the resistor value here is obviously what the user need to enter. So I'm going to enter 200 ohm as requested here by testing, and then I need an inductor value of 200 milli ohm. Then I need a capacitor value for 200 microfarad. So once all of the above are entered, okay, once all of the above are entered, then you know the next thing is obviously to enter the frequency. So I enter the frequency 50 Hertz, and then I hit enter. Then it populates the result. So I get an impedance of 205.42. As you can see, this is exactly what we are getting here. We've got two format specifier for the decimal value. So there was a problem here in this program. Now the problem was when we hit S, as you saw there, when we hit S, we do the calculation for all the required value, and when the result come, we should go back to the output window, but you can see the screen is blinking. There's something is not right there. So if, let's say I enter an invalid selection G. Now this is an invalid selection, but my main window is blinking and returning once again. So let's try that again. Just look what's happening. Invalid window, and then I return again. So that's a problem, because in a normal operation, when I hit O, which is an invalid selection, it should just display invalid selection and come back. It should display invalid selection for 2 seconds and come back. Now if I change the program, and just make it 3 seconds. Just increase it so we can see clearly what's happening there. We'll just run the program again. Okay, there it is. Now I hit an invalid selection G. 3 seconds. Now the thing is flashing. Something is wrong. So the problem was, to fix it, I needed to include this line here that you see, which is a fix. So I needed to include it both after the switch case here. Okay, after the switch case. And I also needed to include it inside our menu function here, where we are checking for an invalid selection. So which means I needed to include it right inside the if statement that is checking whether the characters entered is amongst the ones specified on the menu. So that is what was a problem. So I needed to include this line here, as you can see, ff/stdi. Okay, so the ff lash, or rather say f/stdin, is a C function. Now this C function here got a very easy role, as the name implies. F/flash for function, so it is used to flash the output buffer. So when you're running your program, there is a buffer that is being created based on the things that you've already compiled and you've already run on your output console. So you need this program to always clean your output buffer when you are running and executing an exe file. So this was the main reason we were not clearing our buffer. That's why we were always coming back to that flashing screen for invalid selection. Then we needed to also clear it here, because it was always taking from the menu, the main menu here, where we're checking the switch case. So another f/stdin right after the switch case. And then right now I'm going to run it again, and you're going to realize that the fix indeed went through. So if we just check now I'm going to put another invalid selection H, invalid selection, and I'm coming back. J, invalid selection, and I'm coming back. So the invalid selection is indeed working. Now let's just see. I compile the program again. Okay, now let me just increase this one here for 2 seconds, okay, instead of half a second, and then I compile it again. Then we're going to test it one more time here. So if I hit J, okay, you can see I'm getting invalid selection. I hit a U, I'm getting invalid selection for 3 seconds, and then I'm returning. So the problem have been fixed because of including the f/flash passing a parameter std in, because it's for the input or output buffer. Okay, now so that was the program, and you are more than welcome. I'm going to attach the C code for this program, a Google Drive link where the C code will be posted, and you are welcome to go through the whole program and see how it was written, and the previous live stream are available. Now before I end this short live stream here, I want to demonstrate quickly how we can actually prove this value. As you saw that by entering 200, okay, 200 ohm, 200 millihenry, and 200 microfarad capacitor, we were able to display the frequency, okay, and the correct impedance, and say that it was inductive. So now I want to run a quick analysis on multisim of the same circuit, see if we can indeed verify this value that we got here, okay, of the impedance, and because that is the magnitude of the impedance. Okay, now let's go quickly to multisim here, and we're going to just write our circuit. Basically just draw the circuit using multisim. So where is the circuit? Okay, so the circuit is an RLC circuit. So we're going to first select our resistance. So let's rather add component. Okay, place component. So we go basics. Does that make sense? Resistor. Okay, then we need to find a 200 ohm resistance. 200 ohm. Okay, there is a 200 ohm. Okay, so I'm gonna place my 200 ohm. Then I need to find me an inductor, RLC. Let's find an inductor. It doesn't matter the order so long as it's a series circuit. So we need a 200 milli Henry inductor. 200 milli Henry inductor. Let's just see if we can find the 200 milli. There is a 200 milli Henry inductor. Okay, in series. And then we need a capacitor. The capacitor also, the test circuit says for 200 microfarad. So if we are lucky to find the 200, is 180, 220, okay, 210. But I'm sure we can edit the value. We can edit this value. Let's just double click, see if we can change the parameter of this capacitor. Double click. Okay, let's make it rather a 200 microfarad. Okay, 200 microfarad. Then we need to also now include the source. So let's find the source. Okay, we need to come back here. Source. Okay, so a power source, AC, no problem. So we just place it there. We close. Now let's just change a parameter here. Okay, depending on where you are watching the video from or the live stream. So for me, it's a 230 in South Africa and 50 hertz frequency. So I'll just modify it like that. So that is my RMS voltage. Then obviously we need a ground, because the circuit need to have a ground. So let's just place the ground. Okay, then we place the ground there. Okay, now let's start connecting our circuit. Okay, go this way. Okay, all right, like that. And we need to obviously connect here like this. Okay, so this is our RL circuit, RLC circuit, obviously. Now I'm going to run a sweep analysis, a single frequency analysis basically. So I need to come on simulate, and on simulate, analysis and simulation. Okay, so I come into analysis and simulation. Okay, so what do we have here on analysis and simulation? AC sweep. AC sweep. No, we take a single frequency analysis. So single frequency analysis. So now if I hit auto detect here, it's going to take the 50 hertz because that's the 50 hertz that I've specified there. But if you want to change, you can just change the frequency there. But let's first run for a simple 50 hertz. Then we can also be able to check on this section here where we are simulating for like a 20 hertz. We know that what the impedance is and what's the magnitude of the circuit is. Okay, so if I come here and then we need to change what we want, because we need to get the magnitude and phase, otherwise it's going to give us the in a complex form, so that will be imaginary and real value. So we need the magnitude. Okay, so we can see what the impedance is. Now we need to come on the output here. So on the output, okay, we don't have a probe yet. So let's save. Okay, now I need to add a probe. So let's find a probe, a voltage and current probe. Does this make sense? Voltage and current probe. Okay, so we add a voltage and current probe. How do we put it on? Okay. Place a probe, voltage, and current. There's a, okay, there it is. No, not yet. Okay, voltage and current. Okay, so if the voltage and current probe is placed, then you can go back into analysis and simulation. Then it should be available here on the output. Probe. We still don't have a probe. Okay, there is, no, we still don't have a probe. Do we have a probe? Yes, there is a probe. Okay, but no, something is not right here. This probe is not okay, like that. Now let's try again, because that probe need to be attached to that wire, because okay, what are we getting here? No, this is not correct. Let's find again. Okay, 50 hertz output. Okay, so the probe is now in there. Now we need to add an expression. Now the expression that we need to add is basically the voltage must be divided by the current. So that's the expression that we need to add here. The voltage must be divided by the current. So if, let's see, all the variables are there. Analysis, okay, single frequency, summary, okay, no problem there. Then let's add our probes, add an expression. Okay, so I'm going to, because we know what is the frequency, right? The impedance. The impedance is basically of any AC circuit. Your impedance is your voltage, okay, that is divided by your current. So it's basically ohm law. So if you are calculating a resistor in a circuit, you're going to divide the voltage by the current, and so that will give you the resistor. But and that will be impedance in an AC circuit. So the calculation is that of your voltage divided by your current. Okay, so if, let's take the voltage, so that's a voltage, and then we divide it by the current, okay, and then we copy like that. Okay, so the expression is added there, so that is voltage divided by current, and that expression should give us the impedance. Now let's run, okay, and see if we're going to get something here. Okay, so there is something. So there are some other previous values here, but which we do not want. It's just deleted everything here. Okay, we don't want this table. We don't want this. Okay, let's just run this again. Analysis, it's going to run it. Okay, our parameters is still the same, the output is also still the same. Okay, that's the voltage and the current probe. We want to get the impedance, so that's a voltage divided by the current, and the way we want is a complex number form with a magnitude and phase. So basically a polar form. So when we run it, okay, when we run it, let's run. Okay, so you can see what I'm getting here. I'm getting the impedance here. I'm getting 205.42. That's what I'm getting. 205.42, basically 205 ohm. That's the impedance, and the magnitude, you can see it's a 13.2 phase magnitude I'm getting. So that's based on these parameters here. Now if I changed it. Let's change the parameters. So I'm going to run a sweep again. Now this time I'm going to change my frequency here with a 20. So if I put the frequency 20 Hertz, okay, and then I run, I should be getting a different impedance. As you can see, I'm getting an impedance of 200.5 ohm, and then the phase here is negative, -4 degree phase angle. So if we check on our C programming code, okay, let's just check on the C programming code, and we're going to also now attempt by entering the frequency to be 20 and see if we're going to get exactly the same thing. So I hit S, and my resistance is 200 ohm, my inductor is 200 millihenry, my capacitor is 200 microfarad. Now I need to enter a frequency of 20 ohm, 20 hertz. As you can see, I'm getting 200.4, okay, 0.5, and it is inductive. No, rather it is rather capacitive. Let me maybe just increase the value that I'm displaying, the time in which I'm displaying. It's on a discrete, so that is S. So the time I'm displaying here should just be increased to say, let's just say 7 seconds, so that we can be able to see it clearly. So I'm going to run it again one more time. Let's run it one more time. Okay, and I'm gonna select S. I hit enter. 200, okay, for the resistor, 200 for the inductor, and 200 for the capacitor, so microfarad. And then I will enter, let's just try it again with 20, because that's what we just calculated, 20 hertz. And then we click. So look at it. So the circuit is capacitive. That means the phase is negative. So if we look at it here, there it is. The phase angle is negative. So that means the circuit is capacitive, and the answer is also 200.5. So it is working. And this you can do with a simple analysis like this here, but you can also compute it using a C program like this to really just validate what you've done on your program in a simulation software like this. So that is it for this, and hopefully we can do another C programming for electrical engineers where we can demonstrate how all these things are done. And that is it, guys, and we going to do this again probably next week, but we will find a different topic, obviously, and that will be exciting. So stay tuned for more on this channel. Don't forget to subscribe and keep watching. All right.